Welcome to online lecture series in organic chemistry, and we are discussing the electronic spectra of complexes. In this video we are going to discuss the determination of ground state term for D2 configuration, that is vanadium 3+. For vanadium 3+ or for D2 configuration, number of microstates are equal to 45, that we have seen in earlier video. So this is the representation of D2 electronic configuration, 2 electrons present in D subshell. So for each electron, value of azimuthal quantum number, it is 2, and therefore capital L value, that is orbital angular quantum number, so L1 plus L2 to L1 minus L2, that is 2 plus 2 to 2 minus 2. So value of L ranges from 0 to 4, that is 0, 1, 2, 3, 4. Each L value differ from its neighboring value by 1. So possible L values are 4, 3, 2, 1, 0, and these are the corresponding state symbols. Now there are 2 electrons with these 2 orientations. One orientation is electrons will have parallel spin. In that case, the resultant spin quantum number, it will be 1, that is plus half, that will be 1, and another possibility of resultant spin quantum number 0, that is plus half minus half, that will be 0. So here these are the possible resultant spin quantum number values 0 and 1, and these are the orbital angular quantum number values, that is L values 4, 3, 2, 1, 0. Now each of the L value couple with the S values, and we get the different possible terms and term symbols. So these are the possible L values for D2 configuration, that is 4, 3, 2, 1, 0, and the corresponding symbols, that is G, F, D, P, S. Now S values are 0 and 1, and each of the S value couple with each of the L value. First of all, consider the coupling of the S values with L is equal to 4. So as S is equal to 1, that is the resultant spin quantum number is 1, multiplicity will be 3, because this value of S, it is 1, so 2 ones are 2 plus 1, that is 3, so multiplicity is 3. Now possible J values when L is equal to 4 and S is equal to 1 are, the formula is L plus S to L minus S. So L plus S, that is 4 plus 1, that is 5, and L minus S, that is 4 minus 1, that is 3. So value of J ranges from 5 to 3, and each J value differ from its neighboring value by 1. So possible J values are 5, 4, 3, and the corresponding term symbols are G35, G34, G33. So this 3, it is multiplicity, and 5, 4, 3, these are the J values. Now consider the coupling of S is equal to 0 with L is equal to 4. So multiplicity when S is equal to 4, it is 1. Possible J value is the only one value, that is 4, because here L is equal to 4 and S is equal to 0. So 4 plus 0, that is 4, and 4 minus 0 is equal to 4. So only one J value is possible here, that is 4, and corresponding term symbol is G14. So this 1, it is the multiplicity, and this 4, it is the J value. Now consider the coupling of S values, that is 1 and 0 with L is equal to 3. So when S is equal to 1, then multiplicity is 3. When L is equal to 3 and S is equal to 1, then possible J values are 3 plus 1, that is 4, to 3 minus 1, that is 2. So 4 to 2, that is 4, 3, 2. And these are the corresponding term symbols, F34, F33, and F31. So 3, this is the multiplicity, and 4, 3, 2, these are the J values, and F, this is the state symbol, that is F. Now when S is equal to 0 couple with L is equal to 3, then the possible term symbol we can find out. Before that, the multiplicity, spin multiplicity, it will be 1 when S is equal to 0. Possible J value is the only one value, that is 3, because 3 plus 0 is 3 and 3 minus 0 it is 3, and the possible term symbol is F13. 1, this is the multiplicity, and 3, this is the J value. Now when L is equal to 2, then the S values, that is 1 and 0, couple with L is equal to 2, and first of all the multiplicity, when S is equal to 1 it is 3, that is triplet, and these are the possible J values. How we find out? So L plus S, that is 2 plus 1, that is 3, and 2 minus 1, that is 1. So J values ranges from 3 to 1, it means 3 to 1, and the corresponding term symbols are D33, D32 and D31. 3, this is the multiplicity, and 3 to 1, these are the J values. Similarly, S is equal to 0 couple with L is equal to 2, and when S is equal to 0, the multiplicity will be 1, J value will be 2, because here L plus S, that is 2 plus 0, that is 2, 2 minus 0 is 2, and corresponding term symbol is D12. This 1, it is multiplicity, and 2, this is the J value, and D is the state symbol, because here L is equal to 2. Again, the L is equal to 1 coupled with S is equal to 1 and 0. When S is equal to 1, the multiplicity will be 3, that is triplet, and J values are possible J values when L is equal to 1 and S is equal to 1. So 1 plus 1, that is 2, and 1 minus 1, that is 0. So J values ranges from 0 to 2, that is 0, 1, 2, and the corresponding term symbols are P32, P31, P30. Here 3, this is the multiplicity, P stands for L is equal to 1, and 2, 1, 0, these are the J values, that is 2, 1, 0. Now S is equal to 0 coupled with L is equal to 1, and before that S is equal to 0. When S is equal to 0, then multiplicity will be 1, that is singlet, and possible J values are L plus S, that is 1 plus 0, that is 1, 1 minus 0, that is 1. So only one J values is possible, that is 1, and corresponding term symbol is P11. So 1, this is the multiplicity, and this subscript 1 stands for J value equal to 1. Again, L is equal to 0 coupled with 2 S values 1 and 0. When S is equal to 1, multiplicity will be 3, that is triplet. Now possible J value when L is equal to 0 and S is equal to 1, that is 0 plus 1, that is 1, and 0 minus 1, that will be minus 1. Negative J value is not possible, and therefore are not allowed, and therefore only one J value is allowed, that is 1. And corresponding term symbol, it is S31. This 3 stands for multiplicity, S indicates L is equal to 0, and 1, this is the J value. Again, S is equal to 0 coupled with L is equal to 0, and when S is equal to 0, then multiplicity will be 1, that is singlet, and possible J value, so 0 plus 0, that is 0, 0 minus 0, that is 0. So only one J value is possible, that is 0, and corresponding term symbol is S10. So 1, this is the multiplicity, S indicates L is equal to 0, and this 0 stands for J is equal to 0. So these are the possible term symbols. These are the possible term symbols when L is equal to 4, 3, 2, 1, 0 coupled with S is equal to 0 and 1. Now out of various term symbols, few term symbols are allowed as per the selection rules, and few terms are allowed as per selection rules. Now how to find out these selection rules? Now I have given hint in earlier video, and still you listen carefully how to find out the allowed term symbols or allowed terms as per selection rules. Now here two multiplicities are there, singlet and triplet, and L is equal to 4, 3, 2, 1, 0, and possible states are or state symbols are G, F, D, P, S. So take the G, F, D, P, S as it is. I am writing here G, F, D, P, S. So from either side, any side, start with singlet, and alternately you write singlet, triplet, singlet, triplet. If you start from G, then here it will be singlet, triplet, singlet, triplet, and singlet. Or when one can write singlet for this S, then P will be triplet, D will be singlet, F will be triplet, G will be singlet. Start from any side. So this is singlet, this is triplet, singlet, triplet, and singlet. So these terms are the allowed as per selection rule. So considering restrictions of ML and MS values, these are the allowed terms. Now what are the or which are the allowed term symbols? Now G1, G term with multiplicity 1 is the allowed term, and corresponding term symbol is the only one, that is G14. G33, G34 and G35 are not allowed because they have multiplicity. They have a multiplicity, that is triplet and not singlet. Only G term with singlet is allowed, and therefore from G1 term the corresponding term symbol, that is G14. So this is allowed, G14. So G14 term symbol is allowed. Now consider F3. So for F3, for F term, triplet is allowed. So there are three F3 terms here, term symbols with multiplicities 4, 3, 2. So all these three are allowed, but F13 is not allowed because this F13 has a multiplicity of singlet. There is a singlet. This is not allowed. So F term with multiplicity equal to 3 are allowed, and therefore F34, F33 and F32, these are the allowed, whereas this F13 it is not allowed. Now consider the D1. So D term with singlet it is allowed. So these are the D term. Singlet is allowed, triplets are not allowed, and therefore only this D1, 2 is allowed. Other triplets are not allowed. Other term symbols with triplet are not allowed. Now next is P3. So P3 and P1. So P3 are allowed, P1 1 is not allowed. So these are the allowed. P1 1 it is not allowed. And next is S1. So S31 and S10, these are possible term symbols, but S10 is allowed, S31 is not allowed. So these are the allowed terms, that is G1, F3, D1, P3 and S1, and these are the allowed term symbols, that is G14, G34, G33, G14, F34, F33, F32, D12, P32, P31, P30, P3, S10. So these are the allowed term symbols. Now in next video we are going to discuss how to select the ground state term or ground state term symbol among these term symbols. Now for these term symbols, the total number of microstates will be 45. That part also we will discuss in next video, how for these term symbols number of microstates are 45.